Hello YouTubers, today I'm going to go through Todd Moto's Ngrx store, Understanding State Selectors. Who am I? My name is Anthony Kuong, and you can find my website right there. So let's begin. So what is Ngrx and what are selectors? Well, selectors are pure functions that take slices of state as arguments and return some state data that we can pass to our components. To better understand what selectors are and what they do, it helps see Ngrx state has a data structure, a tree that can be serialized to JSON data. Data is added to the state tree by composing state in reducers. Well, that's the easy part. Now to get data out of the state tree, we have to traverse it to find our property of interest and return it. That can become more complex. You may already know that store.select method is used to get data from the store by passing it a string value. The string represents the name of a slice of state in the store, and we expect this function to return data corresponding to our pizzas property, perhaps an array of pizzas. However, store.select can also be taken as a function instead, which takes a slice of state and returns a property from the state. Both of these approaches represents the concept of selector. We are selecting state. So when we think of Ngrx store as a database, and the selectors are like select in SQL queries that give us back information we want. As our state tree grows deeper, it would become more complex to get state out of the store. We may find ourselves writing complex data transformation logics in our components to get exactly what we need. However, we don't want to do that, and this is where selectors come to play. Just like with databases, we can perform data transformation from within the store by composing selectors to just return what we need. We'll keep our components lean and decoupled from the store. So let's think about the data structures. Let's first visualize this concept of state as a data structure inside of the Ngrx context. We create a JavaScript class store that has a state property and some initial values. Let's pay close attention to the structure of state. The state object is just regular JavaScript object that has properties defined and embedded within. One object property wraps another object property, and so on, creating a hierarchy or tree with a state acting as the root. Traversing the complete state tree looks something like this if we want to fetch our entities. In order to get a particular property, we have to traverse the tree. We build our way to entities like building a chain, and each level down is a link that connects us from state to entities. If we miss any link in the chain, it breaks and we cannot create the connection. Each link in this chain represents a reference to the state property. Hence, we need a reference to products, then a reference to pizzas, and then finally a reference to entities. So what do we mean by reference to a property? To illustrate this concept, we are going to create an instance of the store class and showcase different ways in which we can access the properties of the state object. Now, store is yet another JavaScript object containing a state property in it. So one of the ways we can access the levels of this property chain is through the familiar dot notation. Let's grab our entities using this approach for now. This method is surely easy, but we'll find ourselves typing this chain over and over whenever we need to get to a desired property. This isn't the most efficient approach for reusable logic, and also prone with deep property references if something was to blow up. So what if we could create shortcuts to every link in the chain? We can create functions that return products, pizzas, and entities independently. Well, notice how convenient these functions are taking get entities. The purpose of the function is to pass it some state, and from that state extract and return entity's property. What's missing here is how to pass state to the get entity selectors without using store.state directly. Otherwise, we'll depend again on dot notation. Well, the solution is add a select method to our store class that passes the state object to our upcoming selector function. Our select method takes a callback function and invokes it while passing state as the argument. Using this method to get entities, well, we could pass the states throughout the selectors in a logical way, with each passing get us down a level of state tree till we hit entities. As we've shown before, well, first we can get products. Once we have products, we can get pizzas, and from it get entities. This method is nice and easy, but we can take it one step further and make it declarative and functions by using function compositions to create a single callback that gets passed to select. Function composition is when you get a single result back by embedding functions in each other. The return value of the inner function becomes the argument of the outmost function, and so on. Here we are composing our selectors to give us back the value of entities. Our store Ngrx is initialized with a root state, the top level in our state tree. As we keep our application nice and modular, we are going to create additional entities in a state tree. We keep our Angular apps modular by using feature modules, and Ngrx has support for our tool. Once our lazy loaded Angular module is instantiated, it adds itself to our root Angular app. And the same applies with Ngrx store. And it's automatically bound. Adding this behavior is so easy, and we just register any feature state into feature modules by importing the store module and invoking it with for feature. The first argument for feature contains a string that represents the name of the feature state, and the second argument supplies our reducer, which manages that feature state. The feature name plays a crucial role in creating a state selector for the feature state using a handy function provided called createFeatureSelector. CreateFeatureSelector allows us to get a top-level feature state property of the state tree simply by calling it out by the feature name. So what's happening here with createFeatureSelector? Firstly, we pass it a string that represents the name used to register the feature state in the feature module. It uses the string to look up the feature state from within the root scope object